Today's lesson is on solving equations using addition and subtraction. First, we'll look at our vocabulary. A solution of an equation is a value that makes the equation true. Now we'll look at the table. For the table, we have an equation, x plus 3 equals 7. We're going to substitute in some values and see if our equation is true. So first we'll start with 3. So we'll substitute 3 in for x. So we'll have 3 plus 3 equals 7. 3 plus 3 equals 6, and 6 does not equal 7. So both sides are not equal. Now we'll try 4. So we'll substitute 4 in for x. So we'll have 4 plus 3 equals 7, and 4 plus 3 is 7, and 7 does equal 7. So both sides are equal. And now we'll try 5. So instead of x, we'll have 5. So we'll have 5 plus 3 equals 7. 5 plus 3 equals 8, and 8 does not equal 7. So both sides are not equal. So the value x equals 4 is a solution of the equation x plus 3 equals 7. Now for our first example, we're checking solutions. Tell whether the given value is a solution of the equation. So for A, we have p plus 10 equals 38. And we're going to see if p can equal 18. So we're going to substitute in 18 for p. So in this place right here for p, so we have 18 plus 10 equals 38. And 18 plus 10 is 28. And 28 does not equal 38. So p equals 18 is not a solution. Now we're going to continue with example 1. So for B, we have 4y equals 56. And we want to see if y can equal 14. So we're going to substitute 14 in for y, so we'll have 4 times 14. And we want to see if that equals 56. 4 times 14 is 56. And 56 does equal 56. So y equals 14 is a solution. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. So for number 1, we have a plus 6 equals 17, and we want to see if a can equal 9. So for number 1, in the place of a, we're going to substitute in 9. So we'll have 9 plus 6 equals 17. We want to see if this is true. 9 plus 6 is 15. So we're going to see if 15 equals 17, and that is not equal. So our answer is no. And now for number 2, we have 9 minus g equals 5, and we want to see if g can equal 3. So we're going to take this 3, and we're going to substitute in here for g. So we'll have 9 minus 3 equals 5. 9 minus 3 is 6. So now we have 6 equals 5, which is not a true statement. So our answer is no. For number 3, we have 35 equals 7n. And we want to see if n can equal 5. So we're going to take this 5 and we're going to substitute it in for n. So we have 35 equals 7 times 5. So that would be 35 equals 7 times 5, which is 35. Since 35 equals 35, we know that this is a solution. So n equals 5 is a solution to 35 equals 7n. And now for number 4. For number 4, we have q divided by 2 equals 28. And we want to see if q can equal 14. So we're going to take this 14 and we're going to put it in for q. So we have 14 divided by 2 equals 28. And 14 divided by 2 is 7. So we have 7 equals 28. That is not a true statement. so q equals 14 is not a solution to this equation. Now we'll look at another key idea in some vocabulary. You can use inverse operations to solve equations. Inverse operations undo each other. Addition and subtraction are inverse operations. The addition property of equality tells us if you add the same number to each side of an equation, the two sides remain equal. So if you look, we have 8 equals 8. If we want to add 5 to each side, we're going to get that 13 equals 13, and that is a true statement. For algebra, we have x minus 4 equals 5. We could add 4 to each side, and we can get that x equals 9. We can see by substituting that in, 9 minus 4 equals 5, so that is a true statement. Now for the subtraction property of equality, we can see that if you subtract the same number from each side of an equation, the two sides remain equal. So if we have 8 equals 8, and we want to subtract 5 from each side, we're going to get that 3 equals 3, and that is true. Also, if we have x plus 4 equals 5, we could subtract 4 from each side, and we would get that x equals 1. We could look and see that we substitute that back in, 1 plus 4 equals 5, so we can see that that is true. For our second example, we're solving equations using addition. So for A, solve x minus 2 equals 6. For this equation, we're going to undo the subtraction. We're going to do that by adding 2 to each side. When we add 2 to the left-hand side, we're just going to have x. And then 6 plus 2 is 8. So x will equal 8. We can check this by plugging 8 back into our equation to see if it's true. So if we put 8 back in, we have 8 minus 2, and 8 minus 2 is 6. For B, we have solve 18 equals x minus 7. We're going to solve this by undoing the subtraction by adding 7 to each side. When we add 7 to the left-hand side, 18 plus 7 is 25. And we add 7 to the right-hand side, we just have x. So 25 equals x, or you can say x equals 25. If you substitute this back in, 25 minus 7 is 18. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. So for number 5, we have k minus 3 equals 1. We need to undo this subtraction, and we can do that by doing the opposite. So we're going to add 3 to each side. When we add 3 to the left-hand side, we have k, and 1 plus 3 is 4. If we substitute this back in, 4 minus 3 equals 1. Now for number 6, we have n minus 10 equals 4. We want to undo the subtraction. We're going to do that by adding 10 to each side. So we're going to add 10 to the left-hand side and also add 10 to the right-hand side. The left-hand side would just be n, and 4 plus 10 is 14. Now we'll check this by substituting 14 back in for n, and 14 minus 10 is 4. And now for number 7, we have 15 equals r minus 6. We want to undo this subtraction, so we will add 6 to each side. 15 plus 6 is 21, so we have that 21 equals r. I can substitute this back in and see that 21 minus 6 is 15. For our third example, we're solving equations using subtraction. So for A, we have solve x plus 2 equals 9. For this problem, we want to undo the addition. So the opposite of addition is subtraction. So we're going to subtract 2 from each side. So on the left-hand side, we just have x. And on the right-hand side, 9 minus 2 is 7. So our solution is x equals 7. If we substitute this back in, 7 plus 2 equals 9. Now for B, we have solve 26 equals 11 plus x. We want to undo this addition. Since we have no sign in front of the 11, it's positive, so we would subtract. That would be the opposite of a positive number, would be subtracting 11. So we're going to subtract 11 from each side. So on the left-hand side, we have 26 minus 11, and 26 minus 11 is 15. And then on the right-hand side, we just have x, so 15 equals x. If we substitute in this 15, 11 plus 15 is 26. So our solution was x equals 15. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Solve the equation and check your solution. So for number 8, we have s plus 8 equals 17. We want to undo the addition, so we're going to subtract 8 on each side. On the left-hand side, we just have s. And on the right-hand side, 17 minus 8 is 9. Now if we substitute this back in, 9 plus 8 equals 17. Now for number 9, we have 9 equals y plus 6. So 9 equals y plus 6. We want to undo the addition, so we're going to subtract 6 on each side. 9 minus 6 is 3, so I'll get that 3 equals y. This would be the same thing as saying y equals 3. When I substitute this back in, 3 plus 6 equals 9. And now for number 10, we have 13 plus m equals 20. I need to subtract 13 from each side. And on the left-hand side, I'm going to get m. And 20 minus 13 is 7. So m equals 7. If I substitute this back in for m, 13 plus 7 does equal 20. Don't forget to fill out your notes, and remember to watch the video again if needed.